couple of more surface area problems. These are going to be a little more involved than what you've seen so far. Here we have a half cylinder on top of a prism. And we are looking for the surface area, and we're looking for two answers. One of them in terms of pi, and the other to the nearest hundredth. So we'll solve this one both ways. Now we have to take a look at what this shape is. First thing I'm going to do is add a little bit to the sketch, just so we don't forget about what's behind it. Even though we're only looking at sort of this front part, understand that this is a solid figure and there is a back portion of it. So we have something like this here, something like that, and then we have going across. So we do have a three-dimensional figure, and we just can't see those dashed portions. So this will help us find all of the outer shapes that we need to find the area of. So let's start with the prism. If we are going to dunk this in a large vat of paint, we're looking for all the polygons that get covered with paint. So underneath here, this floor on the bottom gets covered. This wall gets covered. This wall gets covered. And this gets covered. So we have 4 walls plus the floor that would all get covered in paint. This part of the prism does not. This would not get painted, so we do not find that area. So we find floor and 4 walls. So we'll start with that. Prism. We have 8 times 11. That's the floor. We have this wall that measures 8 across, 6 high. And there are 2 of them. The back wall measures the exact same as well. This wall is 11 wide by 6 high, and this is the exact same wall as well. So 2 of those. And that will give us the total surface area of the prism. There we have 88. Here we have 96. Here we have 132. Adding all those up gives us 316 square millimeters of area for the prism. Now let's look at the cylinder. And it's not even a full cylinder. It is a half cylinder. This cylinder here has been chopped in half. So we need to be very careful finding this surface area. When objects get cut, say in half or say in thirds, whatever, we don't automatically cut the surface area in half or divide by 3. When we cut any solid, parts that were on the outside, parts that were on the inside are now on the outside. And that does not always make for a nice clean ratio. For example, cutting a cylinder in half does not just simply, we just divide the surface area by 2. No. Normally, cutting a cylinder in half creates this outside piece. In this problem, it's not on the outside. But let's pretend that this prism was gone and it was just this half cylinder. This piece that was on the inside is now on the outside when we cut a cylinder in half. So it's extra area that wasn't there before. So we have to be very, very careful. Again, there is no one way to just automatically come up with a surface area formula when you cut things. You have to look at each solid individually and look at all the outside shapes one at a time and then see what you have there. Normally with a cylinder, we have two circles and we have the 2 pi RL lateral area. Well, we have a half circle and we have another half circle. We have two half circles. So we have 1/2 pi r squared twice. Plus, now we have to deal with this curved area. Well, that's half of the lateral. That's half of the lateral area. We know it's half because from here to here represents a half circle. So we can apply that same thing as we move along here. From here to here would be half, here to here would be half. We get to the end, here to here is half. This is half of that wrapper. Half of that, if this cylinder is a soda can or a soup can, this is half of the label. So half of the lateral area, using my sounds here, 2 pi r h, not L, h. Half of 2 pi r h. Now again, if this cylinder was by itself, we would have a third thing being added. We would have to add this piece. But in this particular problem, this piece is inside, so we don't need it. Sometimes we would have to consider that. When you cut a cylinder in half, you have three parts. You have the half circles, you have half the lateral, plus you have now exposed this parallelogram. In this particular problem, that parallelogram is on the inside and does not need to be considered. But again, I want you to make sure you don't automatically assume that it's ignored every time. You have to base that on the context of each individual problem. Now we can plug in some things. Well, actually, we can simplify a little bit first. 2 times half pi r squared is just pi r squared. Half 2 pi r h is just pi r h. Now we can plug in some things. If this distance is 8, that's the diameter, radius is 4. The radius is 4. We'll get 16 pi. The height of the cylinder, here's the height of the cylinder. We know the radius is 4, height is 11. 60 pi square millimeters is the surface area of just that half cylinder. Putting this all together, here's your answer in terms of pi. Let me write that a little neater inside there. And notice how that's written. This goes in parentheses. These are not like terms, but they're still in parentheses because this unit applies to everything inside. This is your area, your surface area in terms of pi. 316 plus 60 pi square millimeters. To the nearest hundredth. Well, now for the nearest hundredth, I'll plug in 3.14 for pi, and see what happens. It's not going to give me any more decimals. So as an approximation, it would be approximately 504.4 square millimeters. Again, when you start cutting solids, pay very close attention to what is on the outside, what is on the inside. Don't assume that what you did on a previous problem automatically applies to the current problem. Every problem with cutting solids needs to be treated case by case. Let's look at one more that's a little more complex. Now we have a pyramid on top of a prism. We are told the pyramid is square and the prism is a cube. That makes things a lot easier. So, we need to look at what parts of the prism are on the outside. Floor, four walls. And because this is a cube, the floor and all the walls are identical squares. So we have 5 shapes that are all 16 by 16. Nice when that happens. Centimeters squared. For the pyramid, again, we have to look at what's on the outside. The base of the pyramid, not on the outside. But we have 4 triangles that are. And because this is a square, all 4 triangles are the same. 4 triangles, each triangle measures 16 across, slant height is 10. So this surface area comes out to be 320 square centimeters. Put that all together and we end up with 1,600 square centimeters. In this example, nothing was cut, so we did not have to come up with any sort of new formula on our own. We just had to pay close attention to what was on the outside. The set of problems that goes with this are going to be a little on the tricky side. Do the best you can with them and post any questions you have.